So this is our generic four-step process. Test for proportions. So we are writing this one extremely similar to the one for means, except we're just switching everything to proportion. So we still want to start our state the same way. We are defining our population. And again, I want you to have out your other four-step processes when you do this. So write it the exact same way that you've done the other ones. And then we need to define our parameter. Just a reminder here, we are defining P, not P hat, because we are defining it for the entire population. It is a proportion, so it's always going to start with the word proportion. Write this one however you did before, or what makes sense to you, of successes from population in context. I know that's not how I wrote it before, but whatever makes sense to you there. So we define our population, we define our parameter. So now we need to write out the null and alternative hypotheses. So this is H sub 0, this is H sub A. What's our first symbol going to be? Definitely for this type of problem, it's going to be P because we're dealing with proportions. Here it has to be equals. Here it gets to be one of three: less than, greater than, not equal to, greater than, less than, not equal to. And then what goes here is P naught, which is whatever that initial number value is. So it's called P naught, but it's just some number. We dealt with this with means, and you really didn't think about it with means, but you will have to think about it with proportions. So I'll come back to that when we get there. And then let alpha equal number. And still the same, if not given, use 0.05. Wait, 0.05. I actually wrote it correctly this time. So plan, method. These should be getting easy for method. How many samples? It's one. Is a one sample. That second word is sample. It's proportion, so we only use Z. We don't have to decide if it's Z or T. We are not doing an interval. We are doing a test. And for what type of problem? For proportions. So checking our conditions. We check for random. I want you to write this however you did before. So checking that it's random, assignment or selection. But write that one however you've been writing it so that your notes are consistent. Normal. So in general here, this is kind of the big one that can be messed up. In general here, when we're dealing with normal for proportions, it's n times p and n times 1 minus p that are both greater than or equal to 10. But in this case, we're going to have two different p values. We're going to have a p hat value from the sample. We're also going to have a claimed proportion p value, or population proportion, which is what goes here. So which one would rather use, the one from the population or the one from the sample? We'd rather use one from the population. But in chapter 8, we didn't have the one for the population, so we had to use one for the sample as our default. Well, this time we have both, so which would we rather use? We'd rather use the one from the population. So it is n times p naught, and that's why it actually matters that you understand that that number is p naught, is greater than or equal to 10, and n times 1 minus p naught is greater than or equal to 10. Write out in context, there are at least 10 ... Success, failure, in context. Again, write that out however you've been writing that part out. And we always have to end with, so we can use norm approximation. Then our third condition, independent, 10% condition, nothing changing there. Make sure you write independent. Make sure you also write 10% condition, not just 10%, not 10% rule, 10% condition, which is capital N is greater than or equal to 10 times lowercase n. Writing it out, assuming or there are at least. Again, write this out however you have been. And this is specific to in the population, which this one is also in terms of in the population, kind of. This one you need to write is in terms of population. Normal gets a little funny. You'll see it in an example. All right, so do, what are things we need? We need our n, we need our p hat, we need our p naught, we need alpha, and we need if it is 1 or 2 tail. And so I always write 1 or 2 tail just so that I remember, do I multiply by 2 or not? So test statistic, our equation here, we start with the one from the sample. So that's this one. So our value minus our population value, which is the hypothesized value here, times square root of, in general, n times p, or p times 1 minus p divided by n. Well, which one would you rather use? If we have the one for the population, we'd rather use that. So that applies here as well. So p naught times 1 minus p naught over n. So if you want to write kind of a note to yourself, if you choose to do this, that's where people mess up most frequently with proportion, is accidentally writing p hat in those 4 places. So when you find your number value, you have to draw in shade. I think I switched my colors of what had to be there and what wasn't. And then p-value versus alpha. You can plug in a number here, plug in a number here. It's either going to be less than or not less than. And this is going to be written the same way we have been doing it. So we either reject or fail to reject. What is it that we're rejecting or failing to reject? The null hypothesis that p equals whatever this number was. Since the p-value either is or is not less than alpha, which means we do or do not have enough convincing evidence that and then you're writing whatever the parameter population P population direction of the alternative hypothesis in context. This is the way we always have been writing it out.